So good afternoon, everyone. I will be discussing today two topics which are from Spearman's rank correlation and chi-square test of independence. My name is Brian Pardo Bakulangan, and I will be your reporter for these two topics. Before we proceed for our topics for this report, of course, I would first like to discuss some brief explanation and summary when and how to use these three topics. Of course, for our experiment, kailangan muna natin malaman these characteristics or assumptions para malaman natin if we can use these two, which are correlation and chi-square. So the first main feature of our experiment to consider when choosing a statistical method for your research is what's the purpose of our research. There are two major purposes. First is comparison, and the other is relationship. Basically, comparison trying to understand whether there's a difference between two groups. And for the relationship, it tries to find a connection. So comparison is trying to ask if there is a difference between your variables, and relationship asks if there's a connection between your variables. Examples of comparison could be males versus females, control groups versus treatment groups. Comparisons have at least two groups and we're trying to find a difference. On the other hand, relationship could look like an equation between height and flexibility. In relationship, we are trying out correlation and causation on some sort of prediction from one variable to another. The second thing that we have to evaluate after purpose is the type of data we are looking at. And the two main categories are categorical and continuous. Categorical data is a qualitative. Even if there are numbers as text, those values don't represent any numerical meaning. While on continuous data, it is a quantitative or numerical, whereas you increase the value that represents an increasing amount of that property. Once you figure out your experiments, purpose, and type of data, you can choose between the three main families of statistical tests. Those families include the chi-squared family, the t-test or ANOVA family, and the correlation family. For the purpose of this report, we will be discussing chi-squared family and correlation family. So remember, for purpose has two choices, comparison or relationship. For type of data, could be either categorical or continuous. If your experiment is trying to draw a comparison or find a difference, and you only have categorical data, then you can almost guarantee that you will be working in the chi-squared family. On the other hand, if you're drawing a comparison, we're finding a difference, but your data has categorical and continuous types, that would be the correlation family. So, to summarize, here are the typical characteristics of a chi-squared and correlation family. Once you know which family you're dealing with, you can start to drill down to find a particular test that's appropriate of your experiment. Now, let us discuss the first topic for this report, which is the correlation coefficient as proposed by Spearman. This is also known as Spearman ranks correlation. Spearman correlation was derived by Charles Edward Spearman from Pearson's correlation. Spearman's correlation, by definition, measures the strength and direction of a monotonic association between two ranked variables. To start with the explanation, you may be wondering why parang pareha sila or it is identical with the Pearson correlation test. However, there are two main differences between these two statistical tests. These are the terms monotonic association and linear association, and two ranked variables and two variables. So to start with this explanation, let's first dive in with the two ranked variables. Example is in this table. Ano ibig sabihin ng two ranked variables? On this table, there are MBA students and MPA students in WCC with average scores. Our goal here is to use Spearman's correlation to test that data and measures their association and relationship. In performing a Spearman's correlation test, we should first rank the given data. Usually, the highest number is ranked as 1, and so on and so forth. So this is what the rank will look like after ranking all the data. So the highest scores for MBA students is 99, which means that it is the first rank. For MBA students, the highest score is 98, which means it will be the first rank. Now, what's the benefit of ranking the variables first? We cannot only analyze continuous data, but we can also analyze ordinal data. The value for Spearman correlation is RS, whereas it is interpreted as -1 and +1. Negative RS value indicates there are negative relationship, whereas as one variable increases, the other intends to decrease. Positive RS value indicates positive relationship, whereas as one variable increases, so is the other one. Now, let us discuss the term monotonic association. Monotonic association occurs when as one variable increases, the other variable never decreases. This is an example of a scattered plot showing a monotonic relationship. On the other hand, if the points go up and then down, this means it is not a monotonic relationship. It can also occur when the variable increases, the other variable never decreases. So when we look on our example a while ago, when I plot the data, it will show that the data is a monotonic relationship, which means that I can use Spearman correlation on this data. This is the reason why we should always scatter plot before performing any statistical test so that we'll know what to use correctly. Now we know the Spearman correlation, what the Spearman correlation test is. This time, let's discuss what are the assumptions of a Spearman correlation. So to be able to perform interpret a Spearman correlation, the data should satisfy these following assumptions. The first is your sample should be random. Just like the Pearson correlation test, the sample that is used for your experiment should contain a truly random that is representative of one population of interest. The next assumption is that there is a monotonic relationship, whereas the variables must exhibit a monotonic relationship before you can run the Spearman correlation test. Fourth is the data. The data should contain paired samples to compare. If there is a missing data in a group, then you should remove and not include it in the test before performing a Spearman correlation. Lastly, there should be no relationship between the two subjects or these subjects. This is to avoid bias for the result of your experiment. So always remember that in Spearman correlation, data does not have to be sampled from a normal distribution. This is because Spearman correlation is a non-parametric test, so it does not assume that the data have been sampled from a normal distribution. Ito yung isa sa mga formula na ginagamit to calculate Spearman correlation. But for the purpose of this report, this is the video tutorial that I would like to play for you to understand Spearman correlation. But instead of solving it in a pen and paper, mas maganda siyang gamitin and isolve in a Microsoft Excel. So this video tutorial is from the YouTube channel Top Tip Tayo, and it is entitled Perform a Spearman's Correlation or Rank Correlation Test in Excel. Okay, let's play it.
In this video, I'm going to show you how to perform a Spearman's rank correlation test, and this includes generating a p-value. So a Spearman's rank correlation test is a non-parametric measure of rank correlation, and it is a statistical test used to determine the strength and direction of the association between two ranked variables. If you're interested in performing a Pearson correlation test in Excel, I'll leave a link in the description. But let's crack on with the Spearman correlation test. So here I have two variables, age and BMI, and there are 11 pairs of data in this data set. And the very first thing you need to do for a Spearman correlation test is to calculate the ranks of the variables. So what we want to do is to tell Excel to rank the data in ascending order. So this will assign a rank of 1 to the smallest value, and so on and so forth. Now to do this, I'll use the rank.average formula. So I'm going to click in the first cell, and I'm going to do this for the age variable first. So I'm going to type in equals rank.avg, open bracket, and this is where you want to click on the first data point in the variable, and then add a comma. And then next, Excel is asking you for a reference, so the reference is the whole data set, because it needs to know the whole data set to be able to rank it. Add a comma, and then the order, so we want to sort this in ascending order, so I'm going to enter 1. Close the bracket, and then press the return key. So a value of 35 in the age variable is ranked third, so it is the third lowest value. And what we want to do is repeat that for all of our measures in the age group. Now firstly, what I'm going to do is lock the reference cells by adding in a $sign before the column letter and before the row number, like so. And this will lock these cells so that they won't move when we drag the formula down. So now if I click on the first cell, and then in the lower right hand corner, I want to click and drag to carry on the formula for the rest of the data sets in the age variable. So there are our ranks for the age variable. And what I'm going to do is repeat this for the BMI variable. So again, it's equals rank.avg, open bracket, the first data point, and then add a comma. The reference cells are going to be the BMI variable, add a comma, and then it's 1 to sort in ascending order, and then press the return key. So notice here that this value for the first point is 3.5. So in this instance, Excel has averaged the ranks since there is more than one data point that has a value of 26. Specifically, the value of 26 appears twice, so Excel will average the ranks in this case. So again, I'm going to lock the cells by doing the dollar symbol. And then I'm going to carry on the formula for the rest of the data points in that variable. So now we have calculated our ranks for our two variables. So I'm just going to hide this original data set because we don't actually need this for the Spearman's rank correlation test. So the next thing we want to do is to calculate the Spearman's rank correlation coefficient. So I'm going to click on a new cell and then type in equals and then correl, C-O-R-R-E-L, open bracket. I'm going to select the first variable of the ranked data, add a comma, and then select the second variable of the ranked data, close the bracket, and then press the return key. So the correlation coefficient value in this case is 0.628. So this means that there is a positive correlation between the ranked variables of age and BMI in this dataset. So now let's get a p-value to associate with this coefficient value. And the first thing we need to do is calculate the n. So the n is the number of pairs in the dataset. Now if you have a small dataset, you can just count the number of pairs manually, or you can use the count function in Excel. So you can do equals count, open bracket, and then I'm just going to select the BMI variable, close the bracket, and then enter. So I have 11 pairs. Now it's very important that the data should be paired throughout. If there are missing values in one of the pairs, then you need to remove that pair from the analysis. So the next thing we need to do is to calculate a t-statistic, and we need this t-statistic to be able to determine the p-value. And there are two pieces of information we need. There's the Spearman correlation coefficient and the number of pairs that we've just calculated. And the equation to create the t-statistic can be found on screen. So in a new cell, I'm going to type in equals, open bracket, and the first thing I'm going to do is type in ABS, and open bracket. So this is starting the absolute formula in Excel. And this is because we need the absolute value of the coefficient value. And this is important when you have a negative correlation coefficient value, because if you have a negative coefficient value and you don't change that to a positive number, the absolute number, then this means there'll be an error when you calculate the t-statistic. So this is why we use the ABS formula here. Basically, if the coefficient value in this example was negative 0.62, the ABS formula will change this to positive 0.62. And now, if we carry on with the equation, we need to multiply by the square root, so it's SQRT, open bracket, n, which is this cell here, the number of pairs, minus 2, and then close the bracket for that, and then close the bracket again, and then divide, open bracket, square root again, open bracket, 1 minus ABS, open bracket, the correlation coefficient value again, close the bracket, and we need to do squared, so we want to do to the power of 2. And then I'm going to close that bracket and close the other bracket. So that is the formula in Excel to calculate the t-statistic for this dataset. And I'm going to press the return key. So the t-statistic in this example is 2.42. So the next thing we need to do is calculate the number of degrees of freedom in the data. So the degrees of freedom can be found by subtracting 2 from n. So simply we can do equals n, which is 11, minus 2. So the degrees of freedom is 9. And now the final step is to calculate the p-value. So to do this in an empty cell, I'm going to type in tdist, D-I-S-T, open bracket, and the first thing we want to select is the t-statistic, which is this value here. Then I'm going to add a comma, and then it's the number of degrees of freedom, which is this cell here, add a comma, and then you either enter 1 if you want to do a one-tailed test, or 2 if you want to do a two-tailed test. And in this example, I'm going to enter 2 because I want to do a two-tailed test. Close the bracket, press the return key. So there we have our p-value, and the p-value in this case is 0.038. And if our significance level, our alpha level, was 0.05, since our p-value is less than this, this would mean that there is a significant positive correlation between the ranks of age and BMI in this example. So that is how you can perform a Spearman's rank correlation test by using Microsoft Excel.
Now, the next topic for this report is the chi-square, which is the test of independence. Actually, there are different kinds of chi-square tests, but for this topic or report, we will be discussing test of independence. So, chi-square test of independence was created by Carl Pearson. Now, the chi-square test for independence, by definition, is used to compare observed results and expected results. Basically, it determines and evaluates whether there is a relationship between two variables. Just like in Spearman's correlation, it is a non-parametric test that is performed on a categorical data. That data is measured on a nominal or ordinal data. To determine if you can use chi-square test, you must achieve the following data requirements. First is, you should have two categorical variables. For example, we have variable xy and variable yx. Second is, for each categorical variable, there should have at least two or more categories. We have category X, category Y, category Z, and category A. They should also have no relationship between other subjects in a single population, just like in Spearman correlation. And lastly, there should be a large sample size. Here are the steps in solving chi-square test of independence. So step 1 will be define the null and alternative hypothesis. Step 2 is state the alpha. Step 3 is to calculate the degrees of freedom. Step 4 is to state your decision rule. Step 5 is to calculate test of statistics. Step 6, state the results. And last step will be state your conclusion. So let's take this example. Male will be XY and female will be YX. They were asked which is their favorite letter, either letter X, letter Y, and letter Z. Let's assume that XY are the males and YX are the females. You can see that I have the column totals, 120, 180, and 200. And on the right, I have the row totals, which are 300 and 200. the total number of population or the sample are 500 people. So we can use this information to calculate our chi-square. So again, the first step is define null and alternative hypothesis. For our null hypothesis, x, y, and y, x are not related to one another. So next is, of course, step 2 is to identify the alpha. Our alpha will be 0.05, which is always given pag nagsosolve ng chi-square tests of independence. The alpha will always be, or usually, 0.05. Now, in calculating degrees of freedom, our formula is df is equals to total number of rows minus total number of columns. Okay? So df is the symbol used for the degrees of freedom. So here we have the rows minus 1, or the total row, which are xy and yx. So 1, 2, 2 minus 1. And we have the total number of columns, which are x, y, z. 1, 2, 3 is equals to 3. 3 minus 1 is equals to 2. 2 minus 1 is equals to 1. 1 times 2 is equals to 2. So this is our degrees of freedom. Next, we have, after calculating our degrees of freedom, we can now state our decision rule. We're going to go to our chi-square table, and by using the alpha 0.05 and degrees of freedom 2, we can find the critical value of 5.991. So here is our alpha, here is our degrees of freedom, and here's our critical value, which also states that if our chi-square result is greater than 5.99, we will have to reject our null hypothesis. So let's calculate our chi-square. But before we calculate the chi-square itself, we first have to have our expected frequencies. So in solving expected frequency, ito yung ginagamit natin na formula. Whereas expected frequency is equals to column total, FC, and row total, FR, divided by the total number or the total population number. So in this case, ang una muna natin isa-solve dito ay si row total, which is FR. Row total is 300. Row total is 300, and our column total is 120 para makuha natin yung x, y, and x. Okay? So 120 times 300, tapos i-divide natin yung 500, which is 72. So ganun din yung gagawin natin sa iba. So 300 times 180 divided by 500 is equals to 180, and so on and so forth. So yun lang gagawin natin para makuha natin yung expected frequency. After solving the expected values, we're now going to do the chi-squared. We're going to take all the observed values and subtract the expected values, then square that, and divide by the expected values to get those 6 different fractions. Here's our formula for chi-square. Pag inisa-isa natin siya, observed frequency and the expected frequency squared divided by expected frequency. Tapos yung sagot natin dyan, isa-sum natin. Ito total sum natin. So example, let's derive our expected and observed value. Our observed value here, or observed frequency, is 100. And our expected frequency is 72. Tapos yung resultant is squared natin divided by 72. And so on and so forth. And then, makukuha na natin, i-add natin lahat yan para makuha natin yung ating chi-squared. So after getting the result for the chi-squared, we have 276.389. Ibig sabihin, if chi-squared is greater than 5.99, sinabi natin kanina, we have to reject our null hypothesis. In this case, we have to reject our null hypothesis dahil mas malaki si 276.389 kaya 5.99. Therefore, when we state our conclusion, in our variable, there is a relationship between x, y, and x. Why? Because we accepted our alternative hypothesis over our null hypothesis. Ibig sabihin, si XY and YX are related with one another. Now, just like in coefficient correlation, for the purpose of this report, I will also be playing a video tutorial for chi-square test of independence solved in MS Excel. Again, this YouTube video is from the channel Top Tip Bio, and it is entitled Perform Chi-square Test of Independence in Excel, including p-value. Let's watch it.
In this tutorial, I'm going to show you how to perform a chi-square test of independence by using Microsoft Excel. This includes step-by-step instructions to generate a p-value. As always, please do drop a like on the video if you find it useful, and without further ado, let's jump into Excel and get started. For this example, let's say I have a sample of 200 people that visited my local pub. 100 of these were males and 100 were female. From these subjects, I asked them if they were a smoker or non-smoker. So there were 29 males that smoked and 71 that didn't, and for the females there were 16 smokers and 84 non-smokers. Since these are the actual values from my experiment, they are known as the observed values. What I want to do is to perform a chi-squared test of independence to see if there is an association between gender and smoking status in my sample. The first step to performing a chi-squared test is to add up each of the rows and columns in the contingency table here by using the sum function. So let's add up the values for the smokers column. To do this, in a new cell, I will enter equals sum, open bracket, then I'll highlight the cells in the column, close the bracket, and then press the enter key. So in total, there were 45 smokers. I now need to repeat this process for the next column. To copy the formula across, I can simply select the cell I just calculated, and do you see the little green square in the lower right corner of the cell? Well, click and drag this across to copy the formula. Excel will then calculate the sum for the non-smokers column in this example. As you can see, there were 155 non-smokers in total in my sample. Next, I need to do a similar process but calculate the sum of the rows. So to do this for the males, I will select an empty cell, then I will enter equals sum, open bracket, then I will highlight the two cells in the first row, close the bracket, and then press the enter key. And as mentioned at the start, you can see that there are 100 males in this sample. Again, I will select this cell and copy the formula down to the cell underneath by dragging the little green square. The final thing we need to do here is to calculate the total. To do this, you can either calculate the total value of the columns or the rows, since the answer will be the same either way. I will calculate this using the rows values. So in a new cell, I will again enter equals sum, open bracket, then I will highlight the row sums, then I will close the bracket and then press the enter key. As expected, we have a total value of 200. Moving on, we next need to work out the expected value for each entry in the table. To work out the expected value, you must multiply each row total by each column total, and then divide that answer by the overall total. Let's do this for the male smokers. So here I will enter equals open bracket, then I will select the cell containing the row total, then I will multiply this by the cell containing the column total. I'll then close the bracket and divide by the cell containing the overall total. And finally, I'll press the enter key to run the formula. So we would expect that there would be 22.5 male smokers in this example. I'll repeat this process for the male non-smokers. So in a new cell, I will enter equals open bracket, then I'll select the cell containing the row total, then I'll multiply this by the cell containing the column total. I'll then close the bracket and divide by the cell containing the overall total. Then I'll press the enter key. So we would expect to see 77.5 male non-smokers in this example. I now need to repeat this process for the females. I'll speed this up since the process is exactly the same as I've just shown you for the males. Now I have all my expected values. The next step is to subtract the expected from the observed values, square it, and then divide by the expected value. So I'll do this for the male smokers first. In a new cell, I will enter equals open bracket. Then I will select the observed value, which is this cell here, subtract the cell containing the expected value, and then I'll close the bracket. To square this, you enter the caret symbol, then 2. Then I'll divide this answer by the cell containing the expected value. Finally, I'll press enter to work this out. I get an answer of 1.88 when rounded. I now need to repeat this process for the rest of my table. Again, I can use Excel's autocomplete feature by selecting the small green square in the corner of the cell and dragging it down. Then I will drag it across to the right. Now I have all the values for my table. Next, we need to calculate the chi-squared value. And to do this, we simply add up all of the values in this table we just calculated. So in a new cell, I will enter equals sum, open bracket, then I'll select all of the cells in the table. I'll then close the bracket and then press enter to perform the calculation. So the chi-squared value for this experiment is 4.85 when rounded. Next, we need to calculate the degrees of freedom. Here the degrees of freedom is calculated by firstly subtracting 1 from the number of rows in the test. Then multiply this answer by the number of columns in the test, subtract 1. So my example, this would be 2 subtract 1 multiplied by 2 subtract 1, which gives an answer of 1. So I will add 1 to this cell here. The final step in performing the chi-square test is to take the chi-square and degrees of freedom values and work out the p-value. To do this, in a new cell, I will enter equals chisq.dist.rt open bracket, then I will select the cell containing the chi-square value, add a comma, then I will select the cell containing the degrees of freedom. I'll close the bracket and then press the enter key to run the formula. I get a p-value of 0.028 when rounded. To interpret the p-value, I will state my two hypotheses. My null hypothesis was there is no association between gender and smoking status, and my alternative hypothesis was there is an association between gender and smoking status. If my alpha level or significance threshold was set at 0.05, this would mean I would fail to reject the null hypothesis if p is greater than 0.05. On the other hand, if p is less than 0.05, I will reject the null hypothesis and accept the alternative hypothesis. In this case, my p-value was 0.028. Since this value is less than 0.05, I will reject the null hypothesis and accept the alternative hypothesis. Therefore, there does seem to be an association between gender and smoking status. Going back to Excel, there is in fact a function that you can use to calculate the chi-square p-value by just using the observed and expected table values. To do this, in a new cell, enter equals chisq.test, open bracket, then highlight the values in the observed table, add a comma, then highlight the values in the expected table. Close the bracket and then press the enter key. And as you can see, the p-value is the same as we calculated previously. And that wraps up this video tutorial. You now know how to perform a chi-square test of independence by using Microsoft Excel.
So that's it for my report for these topics. Quick disclaimer, the report study on this research and the articles and its references are intended for purely academic and scholarly purposes only. The author and any of his or her successors or assigns assume no liability nor responsibility for misuse or misunderstanding of the information contained in this report. All studies articles came from their respective authors, and I do not contain these studies videos as my own. And of course, here are the references and internet sources, and of course, also the video links na ginamit ko for our report. Again, hopefully you understood our topic for today. And if may mga tanong pa kayo, pwede nyo balikan yung video na ito para mas maintindihan nyo pa yung correlation coefficient by Spearman correlation and chi-square test of independence. Again, my name is Brian Pablo Bacalangan, and thank you for listening.